Hello, my name is Isaac Lara and I'm an applications engineer supporting position sensing products. In this video, I will discuss how to use the TI Magnetic Sense Simulator TIMS to simulate rotational motion with magnets and TI Magnetic Sensing portfolio. Rotational motion is commonly used to detect the angular position of an object. It is widely used in motor-based applications where a magnet can be mounted to a motor shaft to track absolute or incremental position of a magnet. In TIMS, the rotation function involves a magnet that moves around the z-axis. When the rotational motion type is selected in TIMS, there are a few key input fields used to define the placement of the magnet. These can be found by clicking to expand the magnet motion dropdown. The first is the origin position. This will define the initial starting point of the center of the magnet using the x-axis, y-axis, and z-axis inputs. It is possible to place a magnet anywhere in the 3D space near the sensor. The second row within the origin position will define the orientation of the magnet. Any of the magnets offered in TIMS can be simulated using the rotation motion type, but the most commonly used magnets would be the diametric cylinder and ring magnets. Depending on your system, it may be necessary to rotate about the x or y axis to match the desired magnet to sensor alignment. All rotations are carried out in X, Y, and Z order. Note that the magnet will always rotate around the global Z-axis in 3D space when using the rotation function. The last field in the magnetic motion category will define the arc length in degrees that the magnet will rotate about the Z-axis. The last relevant configuration setting is found after selecting Sim Settings at the top of the input menu. The angular step size field allows the user to determine the angular step size for the simulation in degrees. The tool will create as many evenly sized steps that can be divided from the total arc traveled by the magnet. Here's an example of a mechanical configuration along with magnet and sensor details that can be simulated using the rotation function in TIMS. Feel free to pause the video to view the configuration in more detail. To demonstrate, I'll walk through an example setup of a simulation using the tool. In this case, I will select rotation for the function type and then we'll use a diametric cylinder magnet for this example. For the sensor, I will pick a 3D Hall effect sensor that we can use to detect the changing rotational angle of the magnetic field. For this, I have chosen the TMAG 5170. With all of these inputs selected, we are ready to start configuring the simulation. I will leave the default magnetic material selected as neodymium type N35, but I will change the diameter to 4.75mm diameter with a height of 2mm. We can start by altering the magnet's position by moving the magnet to 5mm in the z-axis and leaving the x and y at the default 0mm. I will leave the arc length for the path of rotation about the z-axis as 360 degrees. Since TIM handles the position of the Hall element of the sensors for users, when you would like to align your sensing element perfectly with your axis of rotation, you must adjust the position of the package accordingly. In this example, I will use the Sensor Position tab to set the sensor below the magnet. The x will be set to the negative 0.27mm and y will be set to 0.04mm. The z position will be changed to 0mm since the package is approximately 1mm high, which will create the air gap of 4mm. Additionally, I will increase the max input under sensor specifications by selecting the 100 millitesla range. Finally, I will set the angular step size to 0.1 degrees. We can run the simulation by selecting the red button that says Simulate towards the bottom of the screen. When the simulation completes, we can observe the motion of the magnet about the z-axis by clicking play with the complete magnetic field information plotted on the right. We can see that the field for this type of motion has great amplitude matching between the x and y axis, which will typically help reduce the possibility of angle error during the motion. And we know that our sensor location and magnet are properly aligned since we do not see a sinusoidal change in the z-axis. When simulating rotation with 3D Hall effect sensors in TIMS, TIMS will yield a graph to display the angle generated by the device. Further looking at the graphs, if we disable the magnitude and BZ fields, we can more clearly see the field in the X and Y direction. If we can look at the angle output, which is labeled as device output 2, we can disable the XZ and ZX angle to focus specifically on the XY angle since it is more linear. We can take the device's generated angle data and compare the device results relative angle to the magnet's angle of rotation in the simulation. This can be used to identify the possible angle error that may exist in your current configuration. TIMS also allows you to simulate possible errors with your magnet's rotation. Since the simulator uses Z-axis as the global rotational point, we can imitate certain common errors seen in magnet rotation and how those could impact your angle measurements. Common mounting issues include magnet runout and magnet tilt. Runout occurs when the magnet is not directly centered to the axis of rotation, so to simulate runout, an offset can be added to the magnet's X or Y position. Tilt occurs when the magnet is not parallel to the top of the device package, so to simulate tilt, an offset can be added in the magnet's X or Y angle. To learn more about TIMS, TI Magnetics portfolio, and more about this type of motion, please see the collateral on the screen. To get started on your rotation motion simulation, please visit www.ti.com/TIMS, and thanks for watching.